you try and build them. Because you've got wires that are going all over the place. You got switches, you might have loose connections, you might have LED lights that are not hooked up in the right order because they have to flow in a particular direction. Now, so if you're old school in terms of how you measure voltage and amperage, in the old school way, when you have like these old amp meters, so this is electricity more so than about any branch of science is steeped in tradition. So when you use an amp meter, and you're using it actually in the old school way, amp meters have to be hooked up in series. Because what it's measuring is how much current is actually flowing through that circuit. So amp meters actually are a part of the circuit, okay? Now, what I showed you on the program was what's called a contactless amp meter. All you have to do is hold it up over the wire. Basically what it does, it measures the value of the magnetic field and it translates it into current. We'll get more into that later. So the old school way of hooking up amp meters is that it's part of the circuit. So right now, my amp meter is reading 0. Now, I closed the circuit, and let me kind of show you what all I've got going on here. So,
just disconnected something.
the first thing that I did, what I have going here, and that's the frustrating part. So, I've got my battery providing energy to the electrons. It's going to go through the ammeter. I've got a switch. And then it's going to go through the LED light, through a 10 ohm resistor, and then back to the battery. So basically what's happening is that you're giving, if you like that analogy, you're giving energy to the electrons. They're going to flow through. I'm going to lose some energy to the resistor. I'm going to use a little bit of energy to the LED light. So I throw that down, boom, I've got a complete circuit. I've got a value of an amp of about 0.4 amps, okay? So I've got this nice little circuit. It's just one thing, everything's in series. But if I want a second resistor, in this case in...
On your phone.
Oh, that's so annoying. Okay? So... Don't worry about it.
Someone needs
So-
to like leave or something, but no.
It's fine.
If it was really important, then make an announcement. No.
So, if I want a second resistor that's then, now how I have it hooked up right now,
The heck?
is that second resistor in series or is that in parallel for those of you that can see?
It's doing something.
I don't even know.
Series.
Parallel, because
I
the
had a
current's flowing
50-50.
through this, and then I'm giving it an outside way to go around.
Oh, okay,
So
that makes sense.
So it's in parallel. So if I close this, there's an interesting thing that happens. Once I put that second resistor in parallel, my current goes up, okay? My current goes up, we'll go through the math later, because once you get currents in parallel, or resistors in parallel, it seems odd, but you actually decrease the resistance in the circuit. But that increases the current, okay? So all I want you to get out of this is that, hey, you can have things in series, you can have things in parallel. Back we go. I think I just told you another ball. All right, back we go.